Okay, so when you hear the word physics, I want you to forget about dusty textbooks and, those impossible equations for a minute. Let's look at physics for what it really is, a grand detective story. Seriously, it's this incredible human quest, thousands of years in the making, and it's all driven by one single profound question.
Right? This is it. How does all of this work? From the absolute first time we looked up at the stars, we've been asking this. Why do things fall down instead of up? What is light, anyway? What are we and everything around us actually made of? This relentless curiosity, is the engine that drives all of physics. So, if you want to get formal about it, physics is our attempt to find the rulebook for reality itself. It's this massive search for the fundamental principles that govern everything. And I mean everything. From the tiniest subatomic particle you can imagine to the biggest supercluster of galaxies out there.
All right, so our detective story, it begins with the first big clues. Those moments we started cracking the codes of the world we can actually see and touch every single day. For thousands of years, we were just observers. Ancient civilizations, they tracked the stars. The ancient Greeks insisted that nature wasn't just random, that it had pauses we could figure out. But the game truly, truly changed in the 1600s. Thinkers like Galileo, Kepler, and of course, Isaac Newton, they weren't just thinking anymore. No, they were measuring, they were experimenting, and they started writing the rules of the universe in the precise language of mathematics.
And this was a monumental shift. I mean, for 2,000 years, Aristotle's ideas, which were based on pure logic, they just reigned supreme. He'd argue that a rock falls because its natural place is on the earth. And, it kind of makes intuitive sense, but it was never really tested. Newton and his contemporaries, they changed everything. They showed that universal mathematical laws, not some vague natural places, govern motion. And the most important part? They proved it with experiments. This new way of investigating became the absolute foundation of what we now call classical physics. And this is where our story gets a major plot twist. Just when physicists thought they had the rulebook for the universe completely figured out, well, they discovered that some very, very strange chapters were missing. Can you just imagine the confidence back then? The laws of motion, gravity, electromagnetism, they worked perfectly. We could predict the orbits of planets, we could build these incredible new machines. It really felt like we were just tying up a few loose ends, that we had almost solved everything. But there were these few nagging clues that just wouldn't go away. Little loose threads. For instance, everyone thought light needed something to travel through, this invisible ether. But every experiment to find it came up empty. And then there were these tiny anomalies, like the specific glow of really hot objects, or the bizarre way that only certain colors of light could knock electrons off a piece of metal. Now, these weren't big, obvious flaws, but they were subtle hints that something was deeply, deeply wrong with our understanding. Classical physics, that rulebook that had worked so well for so long, it just had no answers for these.
So these strange clues, they just couldn't be ignored. They basically forced physicists to throw out the old tools and invent a completely new way of seeing the universe. And that sparked the incredible revolution of modern physics. And what happened next created this fascinating split in the world of physics. See, classical physics is still absolutely perfect for our everyday world, for throwing a baseball or building a bridge. But for the extremes, the incredibly fast world of relativity and the incredibly tiny, weird world of quantum mechanics, well, we needed a whole new set of rules. Albert Einstein, of course, dropped the first bombshell with his theory of relativity. It completely rewrote our understanding of space, time, and gravity. It showed us that they're all intertwined into a single fabric, space-time. This new framework finally solved that mystery of why light's speed is always constant and revealed all the strange things that happen when you get close to it. Now, the second bombshell was quantum mechanics, which is the rulebook for the very, very small. And if you thought relativity was weird, wow. Quantum mechanics revealed this bizarre, probabilistic world where things can be in multiple places at once and energy comes in these tiny, discrete packets called quanta. As strange as it all sounded, it perfectly explained those nagging little mysteries, like the glow of hot objects and the weird behavior of light hitting metal. Which brings us to today, because this grand investigation, this detective story, it is far from over. The cosmic detective story continues, and the cold cases that physicists are working on right now are the biggest ones yet. So our current rulebook, the standard model of particle physics, it's incredibly successful, but we know it's incomplete. We now know that the universe is filled with this mysterious dark matter holding galaxies together, and it's being pushed apart by an invisible dark energy, but we have no idea what either of them are. And get this, together they make up 95% of the entire universe. So the ultimate holy grail, the biggest case of all, is a search for a theory of everything. A single elegant framework that can finally unite the two pillars of modern physics, relativity's world of the very large and quantum mechanics' world of the very small.
In the end, the story of physics is really the story of us. It's our endless, relentless drive to understand. From those ancient stargazers to the modern particle physicists, the quest just continues. And the biggest question of all remains: what profound truth about our universe is waiting just around the corner, ready for the next great detective to uncover?